All right, everyone. So here is page 5 of your Integral 2 review. Okay, so number 20 is just reviewing left Riemann sums and a trapezoidal sum. So the first thing we need to do is establish our intervals. So we're just going to look at the table here. My first interval is from 1 to 5. My next interval is from 5 to 8. And then my last interval is going to be from 8 to 13. And remember, if we're doing a left, a right, or a midpoint Riemann sum, we're just using a regular rectangle, which is just base times height for the area. So if I do this, the base of this right here, let's highlight first. Because it's a left Riemann sum, I'm going to highlight all the numbers on the left. That might be a little bit helpful. Okay, because it's a left Riemann sum, this means I'm going to highlight all the numbers on the left, and those are going to give me my heights. So the base of this first guy is a 4, the distance from 1 to 5, and the height at 1, if I look at the table here, the height at 1 is 1. Okay, then plus the base of this guy is 3, and the height at 5 is going to be 10. And then the last one here, the base of this is 5, and then the height at 8 is going to be that 17. Now, putting these guys together, I'm going to have 4 plus 30 plus 17 times 5, which I believe is 85. And then adding these guys together, this is going to be 34 plus 85, which is 119. All right. Now, a trapezoidal sum, same idea with different formula. So the formula for a trapezoid is 1/2 the base times height 1 plus height 2. Okay, so putting this in, again, I have the same intervals, 1 to 5, 5 to 8, 8 to 13. But this time to get my heights, because it's a trapezoid, I'm going to be highlighting both of them because I have 2 heights in this problem. Okay, so what do I get on the first one? So this guy right here, I'm going to have 1/2 times, the base is 4, that's the distance from 1 to 5. And then the height at 1 is again this 1. And the height at 5 is the 10. Okay, then keep going. 1/2, the base here is 3. The height at 5 is 10. Plus the height at 8 is 17. And then at the very end there, last one, I have 1/2, the base is 5. The height at 8 is 17. And then the height at 13 is 32. Okay, a gross little math problem. Let's see what we got. Okay, so the half of 4 is 2. 1 plus 10 is 11. That wasn't so bad. Then we have half of, okay, this is 3 times 10 plus 17 is 27. And then we have half of 5 times 17 plus 32, which is 49. Oh my gosh, this is getting kind of gross. You guys plug it into your calculator and see what you get. I don't feel like working that out. Sorry. I don't think it's going to be that bad on your test. All right, let's look at number 21. So this is definitely a U sub question because I don't know how to integrate it any other way. So what should I make my U? If you don't know if to make it a sine or a cosine, always make it the one on the bottom and see what happens, okay? So let's make your U equal to sine of x. That means your du is going to equal the cosine of x dx. And then let's go ahead and do our substitution. I'm going to do it over here so I have enough room. So it's the integral of the sine of x becomes the u. And then you guys notice that the cosine of x dx is going to become your du. So all of this becomes the du, leaving a 1 left over on the top. Now I do have to change my bounds, right? So I'm going to plug pi over 2 into here. So that's going to give me the sine of pi over 2. I don't know where to write all this stuff. I'll write it here. The sine of pi over 2, which is up at the top, which is 1. And if I plug in pi over 4 into here, the sine of pi over 4 is radical 2 over 2. So that's going to be down here. Now let's actually integrate this thing. So I know that the integral of 1 over u is the ln of absolute value of u from radical 2 over 2 to 1. And then plugging this in, that's going to be ln of 1 minus the ln of radical 2 over 2. And remember that ln of 1 is 0, so this is really just going to be negative ln of radical 2 over 2. Now look, you're going to notice that none of those answers are there. Now the closest one I would think to these wouldn't be B or C or even E, right? But either A or a D, because they have that 2 on the bottom and they have a radical 2 in there. I would probably go for one of those, but let's see which one it really is. So you guys, this is one of those weird ones where you just gotta know some trig, okay? So what I can do is I can take, this is like a -1, and I can take this and bring it back up to the top. So this is really negative ln of radical 2 over 2 to the -1 power, okay? And there's no negative in front because I just brought it in front. Okay, then that equals the ln. If you raise something to the -1, it flips it. So this is really 2 over radical 2. And then if I rationalize that, if I multiply this by radical 2 and this by radical 2, I'm going to get the ln of 2 radical 2 over 2. The 2's cancel out, so it's just ln of radical 2. Okay, gross little problem at the end, but again, you guys can't emphasize enough that it's not just like this is what calculus gets you. This is what algebra 2 trig gets you. So you have to know those things, okay? So please, like, not saying I'm going to put something that bad on the test, but they might, okay? So please don't discount that. Okay, I have no idea what 22 plus 22 was, but we removed it a couple years ago. I totally forgot. Boris and I both thought it was just a horrible problem. Okay, now let's look at 23. This is what we were working on today. So how do you do an absolute value problem? Well, step number 1 is to split this where x minus 1 equals 0. So that occurs at x equals 1. Okay, and now weird little problem here. Look, now I have to figure out where to split this. So my original integral is from 0 to 1, and I want to split it at 1. You guys, I can't split it. It wants to split at the very end. So the integral is just going to be from 0 to 1 of x minus 1, but then at the end, I have to take the absolute value of the actual answer to make sure that it's going to be positive, okay? So let's see what we get. Okay, so for this one, the integral of x is x squared over 2. Minus the integral of 1, which is x, and I'm evaluating that from 0 to 1. Notice that the 0, if I plug that in, it's going to 0 both of them out, so I can cross that out. So plugging that in, I'm going to have 1/2 minus, and then if I plug that in, I'm going to have 1. 1/2 minus 1 is -1/2, but I have to take the absolute value of it, so it's just going to be positive 1/2. Okay, so it looks like the answer is going to be D. Remember, on these absolute value questions, if any of the answers are negative, cross them out. They have to be positive. Okay. All right, let's look at 24. So it says f of x. Let me rewrite this since I actually have room this time. F of x is the integral from 0 to x of e to the negative t squared dt. Then what is f prime of x? Okay, that just means that I need to take the derivative, the integral from 0 to x of e to the negative t squared dt. Okay, now remember, an integral and a derivative are going to cancel each other out. So this is then going to be FTC2, where that x just drops in. So this is going to be e to the negative x squared plus c. Okay, actually there's not going to be a c because we evaluated it. Sorry. So it's just going to be e to the negative x squared. So this answer here looks like it's going to be e. Okay, so you guys, FTC2. Okay, remember that never really goes away. Make sure that you know that as well. Okay? Let's go ahead and do another page. I feel like I can get 2 pages done. Okay, f and big F and little f are continuous functions. Big F prime of x is little f. What is the integral from a to b of f of x dx? Okay, so I need to find out what is the integral from a to b of f of x dx. Okay, so the question is, what is the integral of f of x? Well, I don't know, but they did give me this. They gave me that big F prime of x is f of x. So if I want to know what the integral of little f of x is, maybe take the integral of this guy as well, right? But I know that an integral and a derivative cancel out, so that gives me that big F of x is the integral of little f of x. So when I integrate little f, I get big F but then I need to evaluate it from A to B. So if I plug this in, I get f of B minus, if I plug this in, I get f of A. So it's going to give me D as an answer. Okay? All right, which of the following is the midpoint Riemann sum approximation of that using 4 subintervals of equal length? Okay, so you guys, it looks like I'm going from 4 to 6. That's really badly written. Okay, so let's draw this out. I'm going from 4 to 6, but I want to make 4 equal subintervals. Okay, so I know the midpoint here is 5. That means this is going to be 4.5 and this is going to be 5.5. Now, a little bit gross, but you guys notice, like, if you're looking at all the answers, they didn't actually simplify it all the way, okay? This is an AP classroom questions. I never liked any of those, but it's okay. All right, so what do? It's a midpoint Riemann sum, so I have to find the midpoint. So let's look at our intervals. So my first interval is from 4 to 4.5. My next interval is from 4.5 to 5. My next interval is from 5 to 5.5. And my last interval is from 5.5 to 6. Okay, and what do I highlight? Well, it wants me to find the midpoint, so I need to highlight the midpoints. So what's the midpoint of 4 and 4.5? That's 4.25. The midpoint of 4.5 and 5 is 4.75. And the midpoint of 5 and 5.5 is 5.25. And the midpoint of 5.5 and 6 is 5.75. Okay, a little bit gross, but it is what it is. So I'm highlighting all of these guys, the midpoints. Okay, now plugging all this in, I don't have any room to do this, but it's okay. I'm going to do it right here between A and B. Okay, so midpoint is still going to be using the base times height. So the base of this first guy is 0.5. So 0.5 times, and the height I have to calculate. The height is not 4.25. I actually have to plug it into here to get it. So it's going to be the square root of 4.25 cubed plus 1. That's just lovely. Okay, now the next one. Okay, the base is the distance from 0.5 to 5, which is again 0.5. And the height, I need to plug in the 4.75 into here. So it's going to be the square root of 4.75 cubed plus 1. Now, you guys, I'm getting kind of sick of doing this. Let's see if I can find the correct answer here. So 0.5 is really 1/2. So if you notice on here, I have a 0.5. All of them are going to have a 0.5. So there's going to be a 1/2 factored out on the outside. So it's going to be either this answer or this answer, right? That has a 1/2. The other ones don't work that way. Now, if I look at this 4.25 cubed plus 1, there's that one. 4.75 cubed plus 1, there's that one. It looks like the answer is going to be B on this one. Okay? All right, let's look at number 27. Okay, this looks like a total U sub problem to me. So what do you think your U is going to be on this one? I think it's going to be 1 minus x squared. That means that your du is going to be negative 2x dx. And if I do my substitution, I'm going to get the square root of u. And then if you look at what the du is, I have a 2x dx left over. There's a 2x dx, so that's going to become my du. I have a 1 on the top to hold its place, but I have a leftover negative, so I got to drop it on the outside. Now, let's change our boundaries. If I plug in 1/2 into here, ooh, that's kind of gross. So that's 1 minus 1/2 squared, which is really 1 minus 1/4, which is 3/4. If I plug in a 0 into here, I'm going to get 1 minus 0 squared, which is just 1. So that wasn't so bad. Okay, now you guys, this problem is just really, really gross, but let's see what we get. So if I rewrite this thing, it's a negative integral from 1 to 3/4 of the square root of u is u to the 1/2. If I bring it to the top, it's going to be u to the negative 1/2 du. And now I can actually integrate. So if I add 1, I'm going to get u to the 1/2. If you divide by 1/2, it's the same as multiplying by 2, and then I'm going from 1 to 3/4. Okay, so this is then going to give me, I'm going to take out the negative 2. Actually, let's write it this way. U to the 1/2 is the square root of u, right? And then it's from 1 to 3/4. So if I take out the -2, and then I'm going to have, if I plug this in, I'm going to get the square root of 3/4 minus the square root of 1. Okay, and simplifying this, I don't see any answers there. I don't see any ln's in my answer, so I can get rid of that. And I don't even see any pi's in my answer. I don't know why there's pi's in here. I can get rid of this, and I can get rid of this also, right? Okay, so this right here, the square root of 3 is the square root of 3, the square root of 4 is 2, and then the square root of 1 is 1. I could do that, right? And then if I distribute this, that's going to be -2 rad 3 over 2 plus 2. So these cancel out, so it's really negative radical 3 plus 2, which looks like it's E as your answer. All right, so there is those 2 pages. So I actually did page 5 and 6 for you guys tonight. All right, I hope that helps, and I'll see you guys tomorrow.